All right, so in this video, I'm going to cover 3.3c, graphing absolute value functions. And I'm going to answer the essential question, how do I graph absolute value functions in vertex form? So again, we're going to use vertex form. But let's first introduce absolute value. So when we're talking about absolute value, we're talking about the distance the number is from 0 on the number line. So the absolute value of 6 would be 6. It's 6 from the number line. The absolute value of -2 would be 2. It's 2 from the number line. Okay? How about the absolute value of 0 minus 5? Well, if you do 0 minus 5, you're going to get -5, but the absolute value of -5 is 5. How about 1 minus 8? Well, the absolute value of 1 minus 8 would be 7. You get -7 when you do the subtraction, but the absolute value of -7 is 7. All right, so let's do an example. For function f of x equals the absolute value of x minus 2 plus 3, let's find the value. So let's do f of 2. So I'm going to do 2 minus 2, absolute value, plus 3. So treat your absolute value like parentheses, because basically parentheses, it's a grouping symbol. Okay, so think of absolute value like parentheses. So they're going to come first in your order of operations. So I need to do that first. Absolute value of 0 would be 0. 0 plus 3, and I'm going to get f of 2 equals 3. Okay? All right, so how about f of 5? Again, I'm going to put 5 in here, minus 2. Absolute value of 3, which would be 3. So the f of 5 is going to equal 3 plus 3. So I'm going to get 6 up here. All right, so how about f of -5? All right, so let's put our function rule here. So we're going to have -5 minus 2, absolute value, plus 3. So I'm going to get the absolute value of -7 plus 3. So f of -5 is going to equal 7 plus 3, which equals 10. All right. So let's look at the vertex form. So you're going to have f of x equals x minus h plus k. So instead of parentheses, you're going to have your absolute value symbols. Again, with the h, you're going to use the opposite sign. Okay, and k, you're going to use the same sign. So let's do an example. We're going to use f of x equals -1 over 4, absolute value of x minus 1 plus 3. So great. First, let's find our axis of symmetry. So remember, that's your h. So x equals, if our h is -1, it's going to equal 1. And our vertex is going to be hk, so we're going to have 1, 3. So remember, go to the center of your table of values, put in your vertex, and then we're going to put the numbers to the left on the number line and to the right. Great. So then you can always write out your function rule without the x. And then remember, you're going to fill in. So again, with absolute values, just like quadratics, you're going to see symmetry. So you should have symmetry here, and you should have symmetry here. Remember, absolute values are shaped like a V. All right, so Let's do 0. So I have to do my parentheses first. So I have -1, absolute value would be 1 times -1/4 would be negative 0.25 plus 3. I'm going to end up with 2.75. Okay. Let's try it again, but this time instead of the, oops, I didn't mean to erase that. I need to keep the -1. But instead of 0, now I'm going to put in my 2. And I should end up with the same number here. 2. So 2 minus 1, I get 1, absolute value. 1 times the -1/4 plus 3. Again, I'm going to end up with the 2.75. It's going to be a symmetrical function. All right, great. So instead, I didn't mean to do that, x, okay. So instead of 2, now let's do our 3. All right, so 3 minus 1 is 2, absolute value, times by -1/4 plus 3, and you're going to end up with 2.5, okay? Because when you multiply 2 times the 1/4, you're going to end up with 0.50 plus 3, you're going to get 2.5. You should end up with the same number when you put in your -1. Let's make sure. -1, -1. So -1 minus 1 is -2. But the absolute value is 2 times -1/4, -0.5 plus 3. We do, in fact, end up with 2.5. So great. Once you get your points, then you can graph. So let's do another example here where we graph. And we also come up with the domain and range. So here is my absolute value function. So remember, your axis of symmetry is going to be x equals h. Well, our h in this one equals 3. I don't have a k here, do I? So my vertex is going to be 3, 0. If you don't see it, remember it's 0. So now I'm going to put that in the center of my graph. I'm going to put the numbers to the left on the number line and numbers to the right. Wonderful. Then if it helps you, you can write out your function rule without the x's. Okay. And then you can fill in your values. Remember, you're going to see symmetry here. Okay, so 4 minus 3 is 1, absolute value of 1 times 1/2. I'm going to end up with 0.5. And I should, 0.5, and I should, when I put in the 2, get the same thing. So 2 minus 3, -1, but the absolute value of -1 is 1 times 0.5. I do, in fact, end up with 0.5. Okay? See how that works? All right, so let's do our 1. Okay, let's do our 1. Oh, 1 minus 3 is -2. You do the absolute value, you get 2 times 1/2, you get 1. And I should see symmetry here, so let's make sure. 5 minus 3, 2, absolute value, 2 times 1/2, and I do, in fact, get 1. So when I graph, I like to do 2 points at the same time. So I start with my vertex, which is 3, 0. So 1, 2, 3 zeros right there. And then I like to graph my 2 and my 4 at the same time. So 2, and I'm going to go to 1, and 4, and I'm going to go to 1. And then I'm going to go to, sorry. No, 2 and 0.5. Sorry. So I'm going to do 0.5 here, 0.5 here, and then when I go to 5, I'm going to go to 1, and when I go to 1, I'm going to go to 1. Okay, and then you can draw straight lines off of it. Remember, it has to be in the shape of a V, right? So then let's do our domain and range. So domain, it's going to the left forever, it's going to the right forever. Infinity, negative infinity to infinity. And my range, well, bottom, it starts at 0. I use a bracket, and it goes up forever. Just like that.